Without initial pose, we estimate the pose of the robot in NeRF map from observed image, which we can define as global localization in NeRF map. As Monte Carlo localization, we utilize a particle filter to localize the camera pose. We initially distribute particles on a NeRF map without prior knowledge for global localization. To weight particles for resampling, we need a rendering process from particles. Rendering many pixels from all particles in a NeRF map is a time-consuming process. From the NeRF map, there are distributed particles in the valid region as red particles and in the invalid region as blue particles. To weight the importance of each particle, we render color from the particle poses. From normal particles, a proper image is rendered, while from abnormal particles, strange image is rendered. To effectively drop abnormal particles, we introduce particle rejection weighting, which estimates the uncertainty of particles. To estimate the uncertainty of particles, we analyze the ray distribution of rendering pixel. With the ray density distribution, we derive the gap between the clear point and the opaque point, which indicates the uncertainty of the particle. Filtering through particle rejection weighting, we effectively drop abnormal particles on the invalid region, which makes localization process faster and easier. To address the time-consuming rendering process, we propose coarse-to-fine multiscale matching, which adjusts rendering resolution, number of particles, and number of pixels to render. We progressively increase rendering resolution, the number of particles, and decrease the number of pixels to render, maintaining total computation as a constant. We demonstrate our localization performance with qualitative results, comparing with LocNeRF. We show quantitative results on left dataset using vanilla NeRF, comparing with existing NeRF localization methods. We also show results on deep blender dataset using ZipNeRF. Experiment results at different thresholds of particle rejection weighting show that particle rejection weighting has a significant enhancement on global localization.